freezing food. You know those things you can buy where you have this big spool with the bags, and you have this vacuum pump in there, and you can put your steaks in there or your chicken, and you suck the air out and freeze it. You can do amazing carbon fiber objects with that method. It's a bit tricky. You have to put in a tube. Anyways, did I tell you about the quick ties? We use so much quick ties, like it's amazing what you can do with quick ties. And of course you use everything else that's useful. Like you used PVC piping from Home Depot for the antenna stands. We used everything that you can get, you know, in Walmart. Walmart has had a good price on lithium batteries, like, and of course you use quick ties. So the other thing that will happen is one of the things JP does, like to kind of nudge NASA a bit on the side, is some educational thing. With every mission, you have excess lift. Like you can put on a kilogram more to fly stuff. So JP thought of a thing called PongSats, and it's an experiment that is put into a ping pong ball to limit, you know, the size, and the weight is limited to, I guess, 3 ounces. Like it should be fairly light, and it doesn't cost you anything to fly it. Like if you want to fly such an experiment, write an email to John Powell, say hello from me, and send him the ping pong ball with your experiment, and it's going to be flown to the edge of space, and you will get it back. And this is, you know, made to excite high school kids for space flight. Like, I mean, NASA does that, but there are alternatives to NASA. And of course, it's a challenge, you know, to put an experiment into a ping pong ball. I mean, those are really fancy things, as you can see. So I'm going to talk about Weight 25 now. That is a mission where I highly participated. Whoops. I'm going to show you a little video again. No sound this time. And this is about the Weight 25. That is a mission where I built a big deal of the onboard electronics. I used a network, an RS-485 network, to connect those basic stems together. And we had a microcontroller on board. Here you can see there were video cameras on board, those PongSats. This is a helium pump for the airship, and that is the electronics box for the airship and the digital camera down there. I will show that in close-up later. There's a parachute on the upper left, again the helium pump, and we got sponsor logos on the sides. I mean, all this is financed by sponsor money. There's no financing from any other sources but sponsors. But for the biggest center, the sponsor is actually the US Air Force, and JP probably doesn't want to get into any deals with those guys anymore. Here you can see the launch. The balloons are released, and those guys are doing a little dance and release the package. Here you can see how the balloons go into the right position. And at this flight, we were actually flying polyethylene balloons. Those are fairly expensive and hard to get. On most other missions, we were flying rubber balloons, like the ones I'm going to fly on Friday. And here you can actually see the onboard camera after launch. This happened in Black Rock Desert, which is about 300 kilometers northeast of Reno in Nevada. It's a big, old lake, like a salt lake. And this is actually the place where Burning Man happens every year, and where the last speed records for cars have been achieved. Here you can see the lake very nicely, and you can see how we get up there. And one thing that happened during that flight, there was a digital camera on board, snapping away, taking digital pictures. And this is the video, and the video only lasted until up, not down anymore. But here you can already see there's space coming up, the darkness of space. You can see the curvature of the Earth. And we want to get up there. but we're already pretty close. I mean, that flight went up to 96,000 feet, which is about, that's about 32 kilometers. But here you can see that that's how it looks when you're really out there. Like now you can really see the curvature, and you can really see how thin the atmosphere is. You can see reflections of the ground. I just love those cloud pictures. I'm going to show some in a few. At this mission, I was actually mission control. I was in charge of starting up the electronics, giving the okay for launch, and like getting the GPS data, giving the commands to the controller. And actually, what happened during that mission is we had those 3 balloons, and at altitude, like at 96,000 feet, one of the balloons popped. So it came down on 2 balloons at about the same speed as it took up, which was really neat. So we got a lot of pictures from out there, and very close to landing, like in 10,000 feet altitude, I gave the command to cut the balloons, and it landed right where we wanted it to land, very close to a road, like we were tracking it on the map. And at that point, we decided, here we cut down, so it comes down at the road, so we can pick it up. Because that desert out there, there's nothing. There's no cell phone reception. There's nothing. The only way to communicate is 2-meter amateur radio or Globalstar. And we didn't have Globalstar. So, yeah, that is the Wave 25 video. And I'm going to show some pictures. Up there is the team. JP is the one to the right in the shade. And there's another few pictures of the package. And here you can see the Pong sets down there. And this little box here is the digital camera. This is the controller for the helium pump. And behind there, this box is the battery. And below that was the controller for the reception and the parsing of the commands. Anyways, that is the big result of that flight, which is a panoramic picture from that altitude. And the thing is, I got something really amazing here. This is a printout of that picture at highest quality on an HP printer. And after my talk, I'm going to auction that off. Like, if it's 1.7 meters times 3 meters. It's like, if you put that into a room, it's like, wow. And this is the 3rd copy of that poster. There's one in John Powell's office. When you sit at this desk, he sees it. There's one in my office, and this one. And we're going to start at 50 euros, but later. So, some odds and ends. I managed to get into the February edition of Penthouse of 2003. What happened is, as an initiation rite at JP Aerospace, you can put on a pressure suit from a Russian MiG-29, which is made here in this beautiful country, in the former DDR. And I was wearing that thing. I said, hey, that's awesome. I can drive my convertible around in the winter. Outside it was fairly cold, so I sat into the convertible, opened it up, put those tubes onto the heater, and drove to the next Wendy's to get some French fries. The girl behind the counter got a hysterical laughter, but I got my French fries and I got back. And I told that story to a guy from Penthouse, and he actually wrote it, including my name, into the Penthouse. So this is another one where, can you see that big rocket behind me? That is an attempt from a Texan guy to fly a rocket into space. And this flight didn't happen. They tried it again 3 months after, and it blew after 3 seconds. Like it went kaboom. Amazing. This is actually the same rocket they flew the ashes of Scotty with. After like 3 flights or so, they finally managed to get that thing not go kaboom after 3 seconds. Texans, they have money. That is actually a band called Space Vacuum, which is having a party at the JP Aerospace spot. And those guys are having way too much fun by putting a disco ball into the mission van. Anyways, what's going to happen on Friday or Saturday at 10 is I'm going to fly a thing called Weg 1. Because in Germany, you know, I can't call that away. Which is this little thing here. I'm going to open this up. It contains, if you can see that, it's a digital camera. It's an RPRS transmitter. It's a microcontroller and a GPS and a cell phone. And we're going to fly that into the stratosphere using a balloon right here on site, Friday or Saturday at 10, depends on the weather. And I actually have a permission to fly that, which is fairly cool, I think. And you can all watch, and I might even need some participation. Like, we're going to send out, like, if you're an amateur radio fan and want to go out and find it, we might need people for the recovery team. But everybody who wants to participate just comes to me after my talk. And yes, if we might even fly a Pong set on that mission, and if you manage to get a Pong set together until Friday, and it's not too heavy, it might be just duct taped to the top of that thing. We're going to fly it, okay? So that's a challenge for you. And yeah, are there any questions? Which one? Oh, but what was the weight of a weight 25? I do. You want to know the weight of a weight 25? To be honest, I can't remember. It was something in the order of 30 pounds, I remember, but I'm not sure. You can get all the information from the web page. I was mainly doing electronics at JP Aerospace, not too much aerodynamics or flight. Any other questions? You need a microphone, I guess. Oh, who? He just asked one. Yeah, I'm gonna front to back. Sorry, guess that's the easiest.
What about fragments in space? Do these things account for that? Like, say, multiple chambers if one gets...
Yes, there might be an issue about that. Probably you have to enforce the tip of that thing, or you have to kind of fly at the right spot to not hit any fragments into space. Yes, that's most certainly a big issue. But that thing is reusable. Like when it's in orbit, it will come back and dock again with the Dark Sky Station. So it's not like space trash. It's going to be a reusable spaceship because it can slow down. Okay.
How do you keep the dark station in the sky, because you have to be at orbit to not fall down. You have to put energy into it.
Oh, you got the ascenders going up and down, like you get supplies. So the idea is to refill the hydrogen or helium.
How long does it usually take to get up to orbital height?
Oh, that's actually a good question. Sorry, I didn't tell you that. The idea is that the process to accelerate into orbital velocity is going to take about a week to 10 days. Like, it takes fairly long.
But how long does it take to get up to 100,000?
Oh, from the ground to, you want to know how long it takes from the ground to the upper stratosphere?
Yeah, like the balloon here.
The one I'm going to fly on Friday? About 1.5 hours.
1.5 hours.
Yeah, you got a climb rate of about 1,500 feet per second. Per minute, sorry.
What is the advantage of starting the rocket from stratosphere?